So I was looking at my hand the other day, specifically at a little piece of gold jewelry.
Okay.
And it gets you thinking. We always hear this phrase, we are stardust.
Right, the Carl Sagan line.
Exactly. But something like gold or platinum,
Yeah.
that's not just stardust. It's something else entirely. It comes from an event so violent it literally shakes the fabric of space-time.
You're talking about a kilonova, the debris from a cosmic collision.
That's where we're going today. We're doing a deep dive into the universe's ultimate gold factories and how these radioactive afterglows are completely changing physics. So what exactly is a kilonova?
Well, to put it simply, it's the light show you get after a massive collision.
Not a star exploding, but two things crashing into each other.
Precisely. Usually two neutron stars, these are incredibly dense, city-sized objects, or sometimes a neutron star and a black hole. They spiral in, merge, and bang, you get this radioactive afterglow.
Now, the name kilonova is a bit misleading, isn't it? It's not just a big nova or a small supernova.
Not at all. The name is purely about brightness. It was coined in 2010 because the event is about 1,000 times brighter than a classical nova, so kilo.
But it's still way dimmer than a supernova.
Oh yeah, only about 1/10 to 100th of the brightness. It's kind of the middle child of cosmic explosions, but it might be the most important one for, creating the elements.
And we had theories about this going back to the late 90s, but we didn't actually see one until that huge Rosetta Stone event in 2017.
October 16th, 2017. A date for the history books. GW 17087. That was the dawn of what we call multi-messenger astronomy.
Because we didn't just see it.
We heard it too. For the first time ever, the LIGO and Virgo detectors picked up the gravitational waves, the ripple in space-time from the collision.
And then moments later,
Telescopes all over the world saw the flash of light, the electromagnetic counterpart, from the exact same spot in the sky.
we heard the crash and then we saw the fireball, 140 million light years away. And in that light, we found the proof.
We found the smoking gun. The spectral analysis showed us heavy elements forming in real time. We saw strontium, yttrium.
The so-called R process elements.
Exactly. That's the rapid neutron capture process. It's this incredibly chaotic environment where atomic nuclei are just bombarded with neutrons faster than they can decay.
And that's how you build gold.
That's how you build gold, platinum, uranium. It proved these mergers were the factories.
Untangling a signal like that from so much cosmic noise takes unbelievable computing power. It's all about finding patterns in chaos.
It really is. Which actually is a perfect segue to our sponsor for today's deep dive.
This deep dive is sponsored by Embersilk. If your business needs help with AI training, automation, or software development to handle complex data, you should check them out.
They help you figure out where AI agents can have the biggest impact on your work or even your personal life. Find them at embersilk.com.
So back to the science. The 2017 event was huge, but the surprises didn't stop there. Just last year, in 2023, a new analysis of that explosion threw everyone a major curveball about its shape.
This was baffling. I mean, truly baffling. Everything we thought we knew suggested the explosion should be flattened, like a pancake.
Because they're spinning into each other so fast,
Yeah.
right? Centrifugal force.
Exactly. But the data showed it was a nearly perfect sphere.
How is that even possible?
The leading theory now involves incredibly powerful magnetic fields generated during the merger. They might be strong enough to kind of smooth everything out and force the ejected material into a sphere.
But the implication of it being a sphere is even bigger.
That's the most exciting part. If they're all perfect spheres, they're predictable. They could become our new standard candles.
It's like a cosmic light bulb. If you know how bright it's supposed to be, you can figure out exactly how far away it is.
And we could use that to measure the expansion of the universe, the Hubble constant, with a whole new level of precision. It could solve one of the biggest debates in cosmology.
Wow, it turns a chaotic explosion into a universal ruler. And the universe just keeps getting weirder. We used to think long gamma ray bursts only came from supernovae.
And now we know they can come from these mergers too. And then just last year, 2025, we got AT 2025 Worlds,
The super kilonova.
a hybrid event. It had features of both a supernova and a kilonova. It's just showing us that these categories we've made are, well, messier than we thought.
It's amazing. These are some of the most destructive events imaginable, but they are literally the creative engines that forged the world around us.
It's a beautiful contradiction, isn't it?
Yeah.
Out of that destruction comes all this creation, all the heavy elements we rely on. And understanding these perfect explosions, as you call them. It's not just about gold, it's helping us measure the cosmos itself.
It's just incredibly optimistic. It feels like our ability to decode the universe is just getting started. There's so much more to find.
I think so too.
Well, if you enjoyed this deep dive into the Cosmic Forge, please subscribe to Intellectually Curious. And hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.